Welcome you all. Today we have to discuss the mathematics of finance lesson. These are the learning objectives. At the end of this session, you should be able to demonstrate the concept of the time value of money, calculate and compare simple and compound interest, and explain their formulas and apply them to various financial scenarios, and then calculate the present value under lump sum, annuity, and perpetuity using the discounting formula. Okay. So let's move on the concept of time value of money discussion. Then actually the simple idea behind this time value of money means the rupee to be received today is more worth than the rupee to be received on tomorrow. Right? That means the today rupee is more worth than the rupee to be received on tomorrow. That is the main ideology, simple ideology and time value of money concept, right? So here you can see actually the idea is that today's specific sum of money is worth more than the same amount in the future. Right? Today, value is more worth than the same amount in the future because time allows us the opportunity to postpone consumption and earn a return. Right? This is the basic idea behind the time value of money concept, right? Okay, so why it is important for you? Why it is significant to learn actually? So in order to avoid the inflationary effect on assets, the time value of money concept is very much required, right? And then to secure the assets return both in the short run and the long run by creating a proper working capital management. Here, what do you mean by the working capital management? I mean the normally the working capital means the money that is required to manage daily day-to-day activities, right, in a business. Okay. So normally we are calculating the working capital by taking the current assets, and then you have to subtract, you have to minus the current liabilities from that current assets, right? And the capital budgeting decisions, that means the decisions that are involving in fixed assets, right? The capital budgeting decisions are all fixed assets. Normally when it's come to suppose like this, you are in a decision to purchase a new machinery into your business operations in that particular thing, the capital budgeting decisions are involved, right? Likewise, right? And then to calculate the cost of capital when a firm is going to raise capital, right? And then to determine the pricing of bond issuance, and then to find out whether lease financing is applicable or not. So all of these concepts, the time value of money, all of these actually factors pinpoints the significance of time value of money, right? Okay. So let's directly move on to the first part, right? In the calculation, so simple versus compound interest. So you can see from the name itself, you can identify simple interest in the sense means it is the interest that means it's applicable only on the principal amount, right? But when it's come to the compound interest, so interest is applicable on both principal amount and cumulative interest earned. So always in the compound interest rather than the relevant interest, we have to take actually, rather than the relevant interest, we have to take the cumulative interest earned plus the principal amount, right? Then only you can come up with the compound interest, right? Okay. So let's look at the formula. So simple interest actually, simple interest is the interest that is calculated on the basic amount, which is called the principal amount or the initial amount, borrowed for the entire period at a particular rate of interest, right? Interest rates. It grows linearly, which is preferred for short-term loans, right? Simple interest is given by the formula is like this. You have to take the principal, that's why the P is there, and then the R, that means the stipulated interest rate, it is given in the question. You have to take it, and then you have to consider the time duration as well. Then read it, and then you have to multiply by principal amount and the interest rate, and then the time duration. Then multiply all and then divide by 100, right? So if the amount, that means A obtained after calculating the simple interest, suppose like this, a question is there, calculate the amount obtained after calculate the amount obtained after the calculating the simple interest, like with a simple question. But you have to do there. You have to take the principal amount, and then for that principal amount, you have to add the simple interest. Then only you can get the The amount obtained after the interest, right? Suppose the example like this. Let me use the pen for you. Suppose the principal amount is 1,000, right? Principal amount is 1,000. 1,000, right? Suppose the relevant interest is 10%. 10% you know. 10% we can get actually 0.1, right? 0.1. How it is came? 10% means it's 10 over 100. Right? 10 over 100 means 0 to 0, cut it off. 1 over 10 means 0.1. So rather than directly writing 10%, I can amend 0.1. Suppose the time duration is 2 years. Therefore, what is your simple interest then in that particular scenario? Your simple interest is 200. What do you mean by the amount then after that, after calculating this simple interest? So this is your interest, right? Interest. Then the amount, then what you have to do, take the principal amount, right? And then plus, you have to add this simple interest. What is the amount then after the calculation? 1,200. Simple like that, right? This is the way that you have to solve, right? It's very simple example, right? Okay, let's move on then. Compound interest. The interest in which the interest of previous years are always in there, the compound interest. In the simple interest, there is no involvement in the previous year's interest, right? But in the compound interest, it is there, right? What you have to do, you have to take the interest in which the interest of previous years is being added to the principal amount for the calculation of the compound interest, right? That is the main thing. Therefore, the compound interest grows exponentially. And this is very powerful for long-term growth, right? And then because why? It increases the cost of borrowing over time, which can lead to higher interest or higher returns compared to simple interest, right? Okay. So the formula to calculate the compound interest is this. Look on the formula. You have to take P, here A means the amount, right? Total amount. So here P means the initial amount or the principal amount, same as the simple interest, right? Same as the simple interest. So take the principal, open a bracket, right? You have to take 1. Here 1 is default. That means 1 is always fixed. It's not changing based on the question to question. 1 is always there. It's fixed. Plus R. What do you mean by here the R? Interest rate, right? You have to divide by N. What do you mean by here the N? The number of times interest is compounded in a year, right? Suppose the interest is compounded daily, then what is your N then? 365. What about the interest is compounded in a month? Then what about here the N? N would be 12 likewise, right? Okay, then here T means the time duration. Rather, time duration, we can take the number of years, right? Number of years. Therefore, even though here we are applying the number of times interest is compounded in a year, here in NT indicates the power of NT means N. You have to take the number of times interest is compounded in a year, and then you have to multiply by the number of years. Suppose the interest is compounded actually a month, therefore N is 12. Suppose your time duration is 2, that means 2 years. Therefore, what is N and T there? It's 24. You have to take the power of 24 for this answer, right? That is the thing you have to follow. Clear? 12 over 2. If it is 365, right? Then here the n would be that. And then what about the years? If it is 1 year, then you have to take only 1. If it is 2 years, then you have to take again t as the 2, right? Likewise, therefore, the formula, just have a look on the formula. A means the total amount you can get as P, principal amount, 1 plus r divided by n to the power of nt. Then you can get actually the whole thing. You have to multiply by the principal amount. Then you can get the total amount, right? This is the formula. Just go back with the simple interest again. PRT, you have to multiply those and then you have to divide by 100, right? Or else you can actually, rather than dividing the 100, you can here, as I aforementioned, 1000 multiplied by 0.1, 2 years. So here there is no any involvement of 100, but here we know the interest is being calculated by what? By what is the way actually? By dividing 10 out of 100. I mean the 10 divided by 100, right? This is how this is kept, right? It's okay. It's okay if you are taking 1000. Here the R would be 10%, keep it as it is, and then 2 years, suppose like this. This is going to be divided by 100. The same answer you can get, right? Here 10 multiplied by 10 means 100. Multiplied by 2 means what is your simple interest? Then 200. The same answer you can get, right? The same answer you can get. Therefore, no worries, right? Okay. Right? Okay. But in the compound interest, when it's come to the simple interest, the amount, total amount, what we have to do, you have to take the simple interest plus the principal, right? But here the compound interest is being calculated by the aforementioned, and then here this is the formula. You have to take the principal amount and then you have to multiply 1 plus r over n power of nt, right? Then only you can get the total amount, right? Then only you can get the total amount, right? Okay. Then most importantly, we will have a look on the present value and the future value. So the present value means what? It's nothing new. You learn actually those concepts by practically. So present value means what is the current value, today value, right? If you are taking a loan, what is the loan amount, right? Likewise, right? If you are taking a loan by today, but after 2 years, right? What would be the loan amount? Likewise, the future value and the present value are being exchange the using, right? Okay. So the present value means it is the current value of a future amount of money or a series of payments evaluated at a stipulated interest rate. But when it's come to the future value, that means the value at some future time of a present amount of money or a series of payments evaluated at a stipulated interest rate, right? Okay, right. Then look on here, future value of a lump sum, right? The future value in 2 years, this is an example. The future value in 2 years of $1,000 earning 5% annually is an example of computing the future value of a lump sum. So lump sum means actually a cumulative one. That means you are being calculated the relevant future value for 2 years, right? A kind of a lump sum, right? Okay. Let's actually focus on the formulas in upcoming session, the slides, right? So when you are to find the answer for this type of question, actually, there are three ways we can use to find the answer, right? That's why we can solve it by three ways. I'm pretty sure you are having with the scientific calculator with you, right? So we can solve this type of a question, right, by using a scientific calculator, right? And then there are the equations, right? In uh, I mean, in upcoming slide, you will be learn actually the relevant equations, right? And then you can use the financial math tables also to find the answer. So don't worry. In the examination, we will be given you the financial math table. In there, the interest is being given, and then the number of interest is being given like this. It's in the vertical axis, right? It's a kind of a table. In the horizontal axis, the relevant time periods are being given. Therefore, what you have to do, suppose like this, if your interest is 10%, you have to calculate the relevant future value after 2 years. Then what you have to do? You have to go back with the relevant periods, and then here the 2 period, 2 years, no? Then the relevant period, the relevant interest is suppose 10%, right? And then you have to go with that actually row with the relevant column, and then suppose the interest would be 0.012 like this. Then what you have to do? You have to take that figure. I mean that answer, that number, right? That number, right? Likewise. Suppose it's 1.0 who likewise, then that figure you have to take, that number you have to take, and suppose uh, your present value is like this, or the future value is like this, you have to uh, get this relevant interest factor, and then you have to multiply and get the answer likewise, right? Suppose the relevant interest is 20%. And after 5 years, what would be the value? Then the same thing you have to follow. Go back with in the financial math table, go with uh, the relevant year, and then check with the relevant interest rate, and then you can get the relevant interest factor, and then amend with that the initial amount. That's it, right? Okay, no worries. I will be teaching you the relevant equations as well. Therefore, no worries. So it's very easy to find the relevant answer by three methods, by these three methods, but you can use one of them, right? So you can actually, if we are providing the financial math tables, of course, in the examination, we are being provided the relevant math tables. If it is, you can use the math tables, or else mathematical equation also you can use. Actually, you can use a program calculator to find the relevant the question as well, right? The answer as well, right? So this is the question. So what would be the formula then? I mean the equation then? Next slide, the formula has been given. The equation has been given, rather the formula, the equation has been given. Therefore, the future value equal to the present value. Here, PV means what? Present value multiplied by interest factor. That means 1 plus I power of n. 1 plus I power of n you have to take, right? That is the thing. Okay. So here actually for the present value, we are adjusted the relevant interest factor, right? Interest rate factor, and then we are being calculated we are being found uh, the future value, right? So this is the formula, right? Okay, so here look on the example again. Here it's 2 years means what is your T, right? What is your T, or else what is your N, time period, right? Here, what about this 1,000? It's the present value. What about here the 5%? It's annually, right? It's annual figure. If it is the month figure or a quarter figure or a daily figure, you have to amend those as accordingly, right? 5% annually means this is your R, right? These are the things. Then we can directly move into the answer. So my advice is first write down the formula, and then first of all write down what is meant by PV. That means your 1,000. What is your I then here? 0.5%. Sorry, the 0.5 or else 5%. And what is your N here? It's 2 years. That's it, right? Then you can substitute the relevant numbers to the equation, right? PV, you know, it's $1,000. And here one I told you, one is not changed into the question to question, it's fixed. Plus I means 0.05. Here N means what? It's 2, right? Take the calculator first, and then press in your calculator, press 1 and press addition, and then press 0.05, right? Here 5, we subtract, we further multiplied, I mean the simplified by 0.05. That's why here it is came. It is actually, yeah, came. It came, right? And then in your calculator, you can see a symbol called like this, right? Press it. This is for the power, right? In the calculation, this is for the power in your calculator. Press it, right? And then press 2. Then you can get some answer. From that answer multiplied by 1000. This is how you have to follow as a steps in finding the solution, right? First, press 1 plus 0.05 and press then enter. I mean, in the enter denotes the equation sign. Press the equation and then you can get the answer as 1.05. From that 1.05, keep it in the calculator, don't erase it, and then keep it, and then press this symbol for the power and then press 2. Then you can get the answer. From that answer, keep it and press this answer and then multiply by 1000. Then you can get the 1102.50, right, dollars. So this is the answer, right? So what would be the future value then? Here the 1000, if you have the 1000 in your hand, after 2 years, the value is actually 1102.50, right? Just because of the interest rate factor, right? That is the future value. Okay. Okay, actually, you may be having some experiences, right? In very good old days, sometimes your parents may be actually told you, we can buy a many number of things if we have 1,000 in that particular time period, right? Suppose 19 period, right? 1976, 1980. But now, if we are having 1,000 and if we are going to the kind of a grocery shop, right? Only one hand bag we can actually have, right? Likewise, right? That is the thing, the time value of money, right? That's why the rupee to be received today is more worth than the rupee to be received on tomorrow, right? Okay, right? That's why the banks are being introduce a interest for them, right? When you are obtaining a loan, right? When you are obtaining a loan, the bank is requesting you to pay a kind of an interest, right? Because of this time value of money, right? That is the thing. Okay. This is the future value formula, right? And then what about the present value then? The opposite side of the future value for equation, I can say. That means here you can see future value is equal to present value multiplied by 1 plus I power of n. So if you are to find the present value, what you have to do? Take the future value. For that future value, you have to divide by the interest rate factor, right? 1 plus I power of n. Then you can get the present value, right? Okay, right. So this is the relevant equation. Present value equal future value divide by 1 plus I power of n. Here, here actually why it is FVN, likewise. Here future value after 2 years, right? That's why. If it is the future value after 4 years, then what would be your n? It's 4, right? Those are same. Right? Right? Okay. So this is the present value for equation. Then look on again, there is a question. How much do you need to invest today? What you have to invest in today? In which amount you have to invest in today? If you want to make a single payment of 30,000 in 18 years, if the interest rate is 8%. Hmm. So here an example for the present value calculation, right? Present value of a lump sum, because you are being calculated the present value for 18th years, right? For 18th year, for 18th years, right? Okay. So here what you mean by this 30,000, it is your what is here the 30,000? It's your future value, right? If you have to make a single payment of 30,000 in after which years? 18th years. In 18th years, if you have to make 30,000 as a payment, as a deposit, right, with the interest rate of 8%, in which amount or how much or how much do you require to invest today? That is the question, right? Therefore, my advice is write down the relevant information evidences here. Future value is $30,000, right? Then here N would be your 18 and then 18 years, right? Or else just 18. And then what is your I? 8%. That means 0.08. Write down the formula. Write down the equation and then list down the relevant evidences, and then you can substitute the relevant numbers, relevant data, evidences to the formula equation, right? So here, if we, 30,000, write it, and then 1, it's fixed, plus here I would be 0.08 power of 18. Then take the calculator, press 1, press plus addition sign, and then press 0.08, right? And then the press equation, and then you can get the answer as 1.08, 1.08, and then press the power symbol, and then press 18. You can get the answer. Keep it and press 30,000, press division, and then press the answer. In the calculator, there is the options, right? Answer. Then you can get the answer as 7,507.47 as the present value, right? Okay. Okay. So 30,000 to be received in 18 years. But when it's come to today, what would be the value of that? Here, around 7,000, right? Okay. Right. Then let's move to the annuities. Annuities, right? Annuities actually two or more periodic payments, but the special thing is the periodic payments are equal in size. The all payments are equal in size. Therefore, periods between each payment are equal in length, right? Okay. There are mainly two types of annuities stemming as, right? Ordinary annuity and annuity due, right? Ordinary annuity means equal amount of money or else equal receipts or equal payments are being received. When it's come to the receipts, it's received, and when it's come to the payments, they are the withdrawals, right? Uh, so the receipts equal amount, equal receipts, so equal size of the payments are being received or paid at the end of each year or at the end of each month, at the end of each quarter. Likewise, end term is there with the equal amounts, right? Those are being labeled as the ordinary annuity, right? If the relevant payments or receipts, but that should be equal, they are being received or paid, right? Paid, beginning of the each year or each month, in that type of annuities are being labeled as the what? Annuity deeds, right? If the amounts, the receipts or payments are branch as the infinite periods, then those are actually perpetual annuities, right? Okay. So ordinary annuity payments or receipts occur at the end of each period, right? This period may be a month, maybe a year, right? It's given in the question. So annuity due means payments or receipts occur at the beginning of each period. Just remember, ordinary annuity, that means OA, they are actually being occurred at the end of each period, but you have to make sure the payments or receipts are equal in size, right? Annuity due, they are actually occurred at the beginning of each period. So the perpetual means it's expected to be continued forever. You can't just say for 10 years, 20 years likewise. It's continued forever, right? Forever. It's forever, right? So it is expected to be continued forever, right? Okay, right. Then in the annuities also, when it's come to the ordinary annuity, there are two types. Types in the sense means two ways to find the answers in an ordinary annuity question. That means whether it may be the present value of ordinary annuity or else the future value of ordinary annuity. Same as that annuity due also, it may be future value and the present value, right? Perpetual annuity, there is no such kind of a ways, right? Okay, let's go back with one by one. Right. Look on the example. Suppose you plan to deposit $1,000 annually into an account at the end of each of the next 5 years, right? If the account pays 12% annually, what is the value of the account at the end of 5 years, right? At the end of 5 years. That is your question. So again, read it. You plan to deposit $1,000 annually into an account at the end of each of the next 5 years. Next 5 years, right? If the account pays you a 12% annually, what would be the value of the account at the end of 5 years, right? So the question is asking you at the end of 5 years, what would be the value? Then what would be the kind of a thing? Is it a future value? Is it a present value? Apart from that, first look on it's a ordinary annuity one or an annuity due. What do you think? Is it an annuity due? Is it an annuity due? No, no, no. It's an in term, right? In term is there. So you can see kind of a lump sum figure, lump sum as well. And then rather than that, in term is there. Therefore, it's kind of a thing. End means the ordinary annuity. And the question is asking you, what is the value of the account at the end of 5 years? So it's directly given you kind of a future oriented thing. Therefore, future value of an ordinary annuity, the question is asking you. Again, you can solve this using a program calculator and solving the mathematical equation and then using financial math tables, right? Okay. Don't worry, we will be learning those in next slide. This is the relevant formula. So if you are to find future value of ordinary annuity, right? In there, what you have to do, this is the formula. Here you can see a term, that means your P, right? When you are referring to some kind of references, you may see instead of A, the authors are being used actually PMT figure or else the C. Don't worry, all are the same things, right? Those are the principal amount, right? I mean the initial amount. Then look on the formula, the equation 1 plus I n, there is no any negative n here, just the plus n, minus 1 divide by I, whole you have to multiply it by a. This is the formula. If you are to find the future value of an ordinary annuity, what you have to do? Take the a, that means your principal amount, multiplied by 1 plus I power of n minus 1 divide by I, right? So here you can see, don't confuse 1 plus I power of n minus 1. Get the answer and divide by interest, right? Interest rate, and then the whole multiplied by the principal. That is the thing, right? So these formulas are very easy to memorize. Therefore, this is the future value of ordinary annuity. When it's come to the present value of an ordinary annuity, the same figures, right? Same letters or same symbols with a very slight difference, right? Okay. So in this example, you can see the 1,000 is your initial amount, right? That means the deposit amount. That means your principal, right? So 1,000, write it, right? And here the one is there. One is fixed, right? Write it. And then plus sign, write it. I means what is your interest rate? Here the 12% annually, right? Then 0.12 is the I, right? 0.112, 0.12. Okay. And then you have to get the 1 plus 0.12. The answer would be 1.12. For that amount, you have to take the power, right? What is your n here? It's directly given in the question as 5. right? You have to take the power of 5. Minus 1, it's not changing. You can see 1 plus 1 and minus 1, it's not changing to the question to question. It's fixed, right? Minus 1 and then divide by 0.12. And then you can multiply the whole by 1000, right? Take the calculator, press 1 plus 0.12, right? And then you can get 1.12, 1.12, and then keep it, press the power button. So you know the symbol now. Press it and then press 5. Get the answer, and for that answer, minus 1, right? Deduct, subtract 1. Then for whole answer, press it and then press the division. And then after press the division, and after pressing the division, press 0.12. Then you can get some answer, keep it and multiply by 1000. Then easily you can get the answer as 6,352.85, right? That is the future value of this ordinary annuity after 5 years. Here also FVAN, here the term, the symbol are there, the letters are there. Here it means after 5 years of an ordinary annuity, what would be the future value, right? That is the thing. Okay. Right. Then, what about the present value of an ordinary annuity? I told you the same formulae, but with a very slight difference, right? When it's come to the future value of an ordinary annuity, what is the formula? A multiplied by 1 plus I power of n minus 1 over I. But when it's come to the present value of an ordinary annuity, what you have to do? A is not changing, A is same. A multiplied by here, even though the future value of an ordinary annuity, the minus 1 is followed by the, the bracket, but now when it's come to the present value of an ordinary annuity, it comes to the front, right? It comes to the front. Therefore, 1 minus, open a bracket, 1 plus I power of minus m, you have to divide by I, right? Same like this. 1 minus 1 plus I minus n as a power, and divide by I, you have to multiply it by A, right? Look on again, in the future value of ordinary annuity, what is the formula? 1 plus I power of n minus 1 divided by I multiplied by A. Don't confuse, uh, you can't actually divide all of the things by I. Step by step, you have to do the answer, right? When it's come to the present value, take here minus 1, come to the front as 1 minus 1 plus I to the power of minus n over I multiplied by A. This is the relevant formula for present value, right? If you can memorize the relevant equations for the present value of an ordinary annuity and the future value of an ordinary annuity, the same thing you can apply to the annuity due with respect to the present value and the future value, but only difference is there. The 1 plus I term is coming for the equations. That is the only thing we will be looking. Right. Okay. Apart from that, we will have just look on the terminologies of nominal interest rates and the effective annual interest rates. I mean, the nominal annual interest rates, rather annual nominal interest rates and the effective annual interest rate. Okay. So you can see in nominal, from the name itself, nominally expressed, right? That means the contractual interest rate for a year which is not adjusted for frequency of compounding, right? In the nominal interest rate, the meaning is actually the contractual interest rate, the interest rate which is in your contract, right? Um, contractual interest rate in the sense means whether it's kind of a bank loan, likewise stipulated interest rate for a year, which is not adjusted for frequency of compounding, right? Contractual interest rate, right? When it's come to the effective annual interest rate means So rather than the nominal, kind of a effective term is there. That means the rate of interest rate, the rate of interest for a year, which is adjusted for the frequency of compounding. So nominal interest rate, the contractual interest rate for a year, which is not adjusted for frequency of compounding. So in the nominal interest rate or the contractual interest rate in there, there is no any adjustments for the frequency of compounding, right? But when it's come to the effective annual interest rate, the rate of interest for a year, which is adjusted for the frequency of compounding. In this effective annual interest rate, the frequency of compounding adjustment is there, but in the nominal interest rate, it's no. Right? So, what would be the effective annual interest rate formula? 1 plus R over M. M means the frequency of compounding, right? If it is the month, then what would be the M? 12, right? If it is, the quarter, what would be the M? Here, the 4, likewise, right? So 1 plus R divided by M. The same M you have to take as the power minus 1. That is the effective annual rate equation or the formula, right? Okay. We learned actually the present value and the future value of ordinary annuity. Then we slightly look on the nominal interest rate and the effective annual interest rate as a partial requirement for this kind of calculations, right? If it is there, you have to find the effective annual interest by applying this relevant equation, right? And then we will now move to the annuity due, right? Annuity. So when it's come to the annuity, I told you, look on here, the ordinary annuity future value formula, the equation A multiplied by 1 plus I power of n minus 1 divided by I. No? Here, just look on the future value of annuity due, the same thing, right? 1 plus I power of n minus 1 divided by I. That should be multiplied by A. But there is a special adjustment, so called 1 plus I. That is the only new thing as I aforementioned. I told you, right? I told you. Therefore, as mentioned, an annuity due differs from an ordinary annuity in that the annuity due's payments or the receipts are made at the beginning rather than the end of each period. That is the difference, right? When it's come to the ordinary annuity, it's actually in the end, right? But when it's come to the annuity due, it's in the beginning of each period, right? Present value also the same formula as in the present value of an ordinary annuity, but with a little bit adjustments in annuity due with 1 plus I. So present value of annuity due, what would be the relevant formula? A multiplied by 1 minus 1 plus I power of n divided by I, right? Divided by I multiplied by 1 plus I. So only thing is you have to memorize only either of the one type of formula, right? When it's come to the present value or the future value of an ordinary annuity, just memorize on that. From that memory, you can actually customize the annuity formula, the equations, right? Okay. Nothing new in the present value of an ordinary annuity and future value of an ordinary annuity. The same figure, the same as the ordinary annuity future value and the present value, but only difference is in the annuity due, you have to take a friend call. I would say a kind of a friend, right? 1 plus I term for annuity due, future value, and annuity due, present value, right? Okay. I mean, the present value of an annuity due and future value of an annuity due, you have to um, take a adjustment so-called 1 plus I. That's it, right? Okay, right. So let's move to the perpetuity then. What do you mean by the perpetuity meaning in finance? Finance, right? Normally, a perpetuity means an investment asset that pays a stated return for an definite amount of time. No, a finite amount of time. No, it's infinite amount of money, right? An annuity with no termination date. We can't set a termination, but we can't set 10 years, 2 years, likewise, 100 years, no, right? 100 years or whatever the years we can't say because it's infinite, right? There is no any termination date, right? So an annuity with no termination date is an example of a perpetuity, right? Because perpetuity is an investment asset that pays a stated return for an infinite amount of time. Okay. So a perpetuity is a type of annuity that lasts forever, right? It's lasts forever. It's not finite, right? It's not finite. It's infinite. The stream of cash flows does not have an end date, right? The stream of cash flows does not have an end date, right? Okay. Then the perpetuity. Let's look on the infinite annuity then. A perpetuity is essentially an infinite annuity. You know that, right? Kind of an annuity, but infinite, right? Okay, look on the example. An example is an investment which costs you 1,000 today and promises to return you $100 at the end of each forever. Is there any particular the time frame? No, right? There is no any time frame. In that sense, what would be the equation then? You have to take the PMT, that means your the cash flow, right? PMT or yeah, the PMT, and then you have to take the present value division. You have to take the PMT and then divide by PV, right? So here the question is actually asking you to find out what is the rate of interest rate. So here actually, if you are to find the infinite annuity for the future, the present value of that, what you have to do, this is the relevant formula, right? I just customize this table, right? You know the cross multiplication, right? If we just use this cross multiplication, you can see PVI equal PMT. So if we have to find the present value, then divide both by I. You can get PV equal PMT over I. The same thing like this, right? So in this particular question, the question is asking you to find out the rate of return, right? Interest rate, right? In that sense, you have to follow the relevant equation, right? Okay. Read it the question again. An investment which costs you 1,000 today. Hints, right? These are the hints. 1,000 today means your present value, your PV, and promises to return to you, $100 at the end of each forever. At the end of each forever, you will be actually returning a kind of $100, right? That means your payments, right? Payments or then the receipts, right? In this particular thing, payments or it may be receipts as well, right? So here, in that sense, the question is asking you to find out the rate of return or the interest rate. So if you are to find the perpetuity value, that means here infinite annuity equal payment, right? Equal receipts. Here 100 is actually being received by you at the end of each forever. Infinite but equal amount, right? That means the annuity. In that sense, if you are to find the present value, but it's a formula. Present value equal PMT divide by I. This is a relevant formula. Okay. So in this question, the question is asked to figure out the interest rate. Therefore, what is your PV? Here the present value is 1,000, right? Here what is your PMT? The relevant payments or the receipts 100, but you do not know about I. Take the calculator and find out I. Here you can use the cross multiplication. 1,000 I equal 100. If it is I, we have to divide by 1,000. Then what would be the answer? 1 over 10 means 0.10, 0.1. That means if it is when it's come to the percentage adjustment, then it's 10%. So what would be the interest rate there? 10%, right? Okay, right. Look on the another example. here the present value of a perpetuity. The same thing I have been aforementioned in the previous slide. Another investment pays $90 at the end of each year forever. So in this perpetuity, we can't say kind of annuity due perpetuity, ordinary the ordinary annuity perpetuity likewise. There is no terms like that, right? Just the present value of a perpetuity. So look on the example. The investment that pays $90 at the end of each year forever, if 10% is the relevant interest rate, right? What is the value of this investment to you today, right? That means your PV. We need to solve for the present value of the perpetuity. So you know the formula now. Present value equal PMT over I. So here, what would be the PMT? The kind of a receipts or the payments value, right? Payment value. So 90 divided by here I means your interest rate. That means 0.1 or else 10%. Then what would be the present value, today value? If at the end of each year forever, if you are getting 19, right? 90, then what would, with the interest rate of 10%, what would be the present value of them? Because the payments are being received or paid or receives or the payments are being received or paid at the end of each forever. No? So that means the answer would be, the present value would be $900, right? This is the thing. Okay, all right. Let's move to that is the thing actually, right? If I go back with the beginning of the slides, we learn interest, simple interest rate, compound interest rates, and future value, present value, and then how to calculate them, and then we learn you know, the the annuities, right? Annuities are the equal payments in size, right? I mean, the periods between each payments are very equal in length, right? All payments are equal in size. Two or more periodic payments we learn as annuities, right? Types of annuities we learn, and then ordinary annuity, future value. And then present value of an ordinary annuity, future value of an ordinary annuity, and then we learn then what is the difference between the nominal interest rate and the effective annual interest rate, right? If you are to find the kind of an effective annual rate interest rate question, you have to follow this formula, right? I told you M may be different. If it is the frequency of compounding is monthly, then M would be 12. The same thing you have to take as the power, right? In the nominal interest rate, there is no any adjustments for the frequency of compounding, but in effective annual interest rate, the frequency of compounding adjustments is there, right? And then we learn the perpetuity, right? And then, if it is an infinite annuity, we learn how to calculate the present value of an perpetuity likewise, right? Now it's time for the questions, right? You can see there are 5 questions I have been aforementioned in this slide. Let's look on the answers, right? Okay. The first question, it's asked you to find out Mr. Tulshan wants to make an investment of rupees 500 million, right? Uh, 500,000 for 6 years. He has two alternatives. First alternative provides him a return of 8% compounded annually, and second alternative provides him a return of 7.5% compounded semi-annually, right? Semi-annually. Uh, which alternative should he select? Which alternative should he select, right? Okay. So what would be the answers? The first alternative here, what we have to find is actually we have to find the present value or the future value. In this question, we have to find the future value. After comparing the future value, we can, uh, give him a solution, right? Which option would be select more? The first option, alternative, we know the formula, future value equal present value 1 plus I power of n. So if we go with the first alternative here, the present value is 500,000, it's same. 1 plus, what would be the I in the first option? 0.08, 0.08. What would be the N then? Here, the 6 years, right? Here, why here I have been taken 6 years? There is no any adjustments, right? There is no any adjustments for just the 6 years annually, right? Then this is the answer. around 7,000, yeah, 793,473.16. When it's come to the second alternative, it's compounded semi-annually. Semi-annual means half annually, right? Semi-annually. So there are how many semi-annual periods for a year? It's two, right? It's like your M. When it's come to the effective annual interest rate, it's your number of, if it is your number of compounding as semi-annually. So what is your M then? Here the two, right? Then here you can see actually since the semi-annual component is there, we have to do a little bit adjustments for that. What is it? What is the adjustments to be made? Here you have to take I, of course, I, you have to divide by M, and then the same you have to multiply it by the same by the N. Why? Because it's not the annual thing, it's a semi-annual, right? Therefore, this interest rate has been given you as the annual thing. Right, annual thing, you have to do the semi-annual for that. Therefore, 0.75 you have to divide by 2. Why 2? Because for a year, semi-annual periods are 2. That's why we are dividing by 2. But when it's come to the n multiplied by m thing, so n here, the same thing, number of years is 6. If semi-annual periods are 2 for a year, how many semi-annuals for a 6 years? Then 6 multiplied by 2. That means 12, right? 12. That's why in the answer, I have been directly taken as 500,000 over 1 plus, right? 1 plus 0.75 divide by 2. Why? Because the semi-annual, if it is the annual, it's no worries. We can just take it as it is annual. But since the compounding adjustments is there, we are dividing the interest rate by relevant compounding periods. And we have to do the same for this n as well. That means n multiplied by m, right? So the formula, if it is the semi-annual or month or daily figure, you have to do a little bit adjustments as PV1 plus I divide by only I, right? Only I divide by M, and N, you have to take N as the main thing, M, and you have to multiply it by M, right? This is the same thing. This is the thing. If you are to find a kind of a different answer with the compounding periods, right? If it is semi-annual, here your M would be what? 2. If it is compounded monthly, what is your M then? It's 12. If it is daily, what is your M then here? 365. If it is quarter, right? Quarter, how many quarters for a year? 4 quarters, right? If it is a quarter figure, then you have to quarter indicate 4, right? But quarter indicate, I mean, the quarter, normally the quarter means 3 months, right? 3 months of period. How many 3 months period for a year? It's 4. That's why 4 came, right? Don't worry. Always the quarter means 3 months. 3 months period. How many quarters for a year? How many 3 months period for a year? It's 4. That's why the 4 came. So therefore, quarter is not 4 months. Quarter is a 3 months period, right? 3 months period. Quarter is a 3 months period. We can find actually 4 quarters for a year. That's why we are taking 4 as the end, right? Okay. So, which future value has the highest growth? You can see the annual figure, right? Because in the semi-annual period, the annual interest rate has to be actually compounded for the semi-annual, right? Therefore, the first option, he or she, here the he has to be selected, right? He has to be selected since it's give the uh, the future value, right? Okay. The second one, how much you deposit, how much must you deposit at the end of each of year in an account that pays an annual interest rate of 12.5%. If the end of 5 years you want rupees 100,000 in the account, right? So here you can see the end term is there, kind of a thing, right? The ordinary annuity thing. It's directly given in the question as in the example, right? If we want I mean 100,000 in after 5 years, what would be the uh, I mean the deposit amount today? I mean, rather than today, what we should deposit at the end of each of these years, right? That is what the question is asking here. That is the kind of a principal amount or your initial payment, right? Can you remember the formula for the future value of an ordinary annuity? A multiplied by 1 plus I, power of n minus 1 over I, right? Here, future value of an ordinary annuity, it has been given as directly given, right? If you want if you want 100,000 after 5 years, that is your future value, right? Write it. And then here, you do not know about A, right? That is what the question is asking. How much must you deposit at the end of each year, right? A is what you have to find. Therefore, A from the term, keep it as A. 1 plus what is your interest rate? 0.125. Is there a compounding thing? No, it's annual rate, right? Annual interest rate. It's given in the question. What is n then? Here 5 minus 1 divided by 0.125, right? Then type it, the answer, I mean 1 plus 0.125 power of 5 minus 1 and then divide by 0.125. You can get some answer as 6.4163. Just round it up and then multiplied by A. And then here the left hand side, the 100,000 is there. You can actually get the A value as 15,565.70 as the A. So that means at the end of each year, you have to deposit, right, rupees 15,564.40 cents in order to find, in order to have, in order to require rupees 100,000 after 5 years, right? Third question. Okay. So the third question, a bank offers you a loan of rupees 1 million at an interest rate of 12% for a period of 5 years. What is the value of an installment if installments are paid at the beginning of each month? So here you can see the interest rate has been given as the annual, but the question at the end is asking the each month, right? So there is the adjustment to be made in if there is a compounding effect. That means if we take the future value, that means PV 1 plus I power of n. So here, if there is a compounding thing, what you have to do, wherever I is there, you have to do the amendments, divide by m, that means the number of compounding periods, and then do the same adjustment for n as well, right? N as multiplied by m. Likewise, the same thing in this question also, where you find I, you have to do the adjustments by divide by number of compounding. And the same thing you have to do the n as well. That means the number of periods, right? Okay. So in this question, by looking at the question, you can see it's kind of an annuity beginning term, right? And what about the future value or a present value? It's a future value or a present value thing. It's a PV, that means the present value, right? Present value thing. Therefore, you know why the present value? Because a bank loan offers a loan means the bank offers you a loan by now, the today value, right? 1 million. 1 million, right? And then the PV, always remember that the bank offers you a loan by now, right? It's today value. Therefore, 1 million equal A is what you have to find, because what is the value of an installment if installments are paid at the beginning of each month, right? 1 minus 1 plus 0.112 divided by 12 by each month, right? I told you if it is a month, your M would be 12. If it is the daily, your M would be 365. If it is semi-annual, your M would be 2, likewise, right? 12. What about the power? You can get the negative, right? Always a negative power in the annuity due. Minus mn means minus 5 multiplied by 12. Here, look on 5 years. So how many months for a year? You have to divide by, you have to multiply by 12, right? 5 multiplied by 12, that means for 5 years, there are 60 months, right? That's why. That is the meaning, right? And then divide by 0.112, divide by 1 divide by 12, and then multiply the whole by 1 plus 0.12 divided by 12. Okay, let's do the calculation with me. First of all, place 0.12 0.12 divided by 12, right? Then you can get 0.01, right? Keep the answer as it is and add 1. 1 plus in the calculation, there is a button called ANS, press it, right? Then you can get 1.01, right? Then for that, you have to take the square, I mean the power, right? Answer, press the power button and then 60, but with a negative minus sign, right? 6. Then your answer would be 0.550449615, right? You are done with that. Then 1 minus from this answer. So 1 minus, press the ans button. Then you can get 0.449550384, right? That is the answer. And then whole thing you have to divide by 0.01. Then you can get 44.95503841 multiplied by 1 plus, open a bracket, 0.12 divided by 12, right? Then you can get the answer as 45.40458879, right? So this answer multiplied by n, therefore 1 million, right? 1 million divided by this answer, then you can find the answer as rupees 22,224.20. So this is the value of the installment of an installment if installments are being paid at the beginning of each month. Okay, let's focus on the fourth question. Mr. Silva is planning ahead for his son's education. He's 10 now and will start university education in 10 years. How much will they have to set aside at the end of each year to have rupees 650,000 in 10 years if annual interest rate is 7%? It's same like the question number 2, right? So question is directly given you to have rupees 650,000 in 10 years, right? What would be the what would be they have to I mean how much will they have to set aside? Therefore it's kind of a future value. Why? Here from I mean by reading you can understand it's a ordinary annuity thing because at the end of each year. So here future value means to have rupees 650,000 in 10 years means of course it's a future value, right? Write down the formula. Future value of an ordinary annuity means A multiplied by 1 plus I power of n minus 1 divided by I. Okay? So here future value of an ordinary annuity is 650,000 and equal A is what you have to find multiplied by 1 plus 0.07. That means your interest rate. There is no any compounding adjustment. Therefore, it's no worries about the M, right? This is the annual interest rate. Then N would be 10 years and then minus 1, 0.07, right? First, press 1 plus 0.07. That means 1.07. Press power button and then you can get the answer as 1.967151357 minus 1. Right? I'm again repeating. The answer would be 1.967151357, right? Minus 1. Then you can get the answer as 0.967151357, right? This answer you have to divide by interest rate. That means 0.07. The answer would be 13.81644,796, right? So that is multiplied by A. That means you have to isolate A and divide 650,000 divided by 13,000. I mean the 13.81 644,796. That means you can get here this part. The answer would be actually 13.816, right? I have been taken only 3 digits, right? And the whole number is actually 13.81644, 13.81644,796. So this answer is there. You have to isolate A. You have to find A. Therefore, we have to find A by doing the other part. I mean 650,000 divided by 13.81644,796, right? Then you can get the answer as the value they have to I mean, they have to set aside at the end of each year is 47,405.376, or else if you just uh, divide by 650,000 divide by 13.816, the answer would be 47,000 four 46.91. That means 90. 47,046.09, right? 47,046.09. If you use this rounded figure, but if you use the whole number rather than the rounding, you can get a different answer. But don't worry, different answer with the same figure, right? Same answer, right? It's depend on the rounding actually. Okay, so the final answer would be 47,046.90. Right. Okay. The final question. A life insurance company has offered a person a new policy that will be fully paid up when he turns 50. At that time, it will have a cash surrender value of rupees 180,000 when he turns 70. The policy will have a cash surrender value of rupees 377,280. What annual rate of interest is the insurance company promising on his investment? So here, is there ordinary annuity or annuity calculation? No, no, no. It's a future value thing. Therefore, the question is asking, not directly asking the future value or a present value, but you have to have the understanding of that. There is no any end or beginning terms are being attached. Therefore, it's kind of a thing to find out the interest rate. Therefore, interest rate we can easily find by this equation, present value or the future value equation, right? So future value equal present value 1 plus I power of n. So here, what would be the future value? When he turns 70, that means the future, right? 377,280. What about the present value? When he turns 50, right? When he turns 50, that means it's present value, 180,000. One is there, but what about the I? I is what you have to find. What about N? N is the difference between 70 and 50. That means future, if he turns 70, that means now if he turns 50, you have to take the difference. 70 minus 50 means 20. Right? Okay, if I use a hint, you know the square root, right? Square root normally in the square root, we are not providing 2, right? But you know it's 2, right? If it is 16, that means half of 16, right? Half of 16, that means that is how the 4 comes, right? That is how the 4 comes. Likewise, right? Right? 4. That is how the 4 comes, right? And then what about here if it is 27, but the 3, that means 27 of 1/3 of 27th, right? What would be the answer? It's 3. Likewise, right? The same thing you have to do here, right? Here you can see actually we have to find I, right? We have to isolate I. Therefore, you can see the power of 20 is there. We have to eliminate this 20 power by putting the square root of 20 to the other side. So, you know, 20 square root means kind of a 1/20th, right? Therefore, you can solve this equation by this way, right? Here, always remember I is what you have to find actually. Therefore, I, you have to keep aside, right? Therefore, you can actually get rid of 377,280 divided by 180,000, 80,000, right? Equal 1 plus I power of 20, right? Take the calculator and press 377,000. Yeah, 377,280 divided by 180,000. Then the answer would be 2.096, right? 096, 2.096 equal 1 plus I power of 20. Right? And then what you have to do here, the 20 is there, right? 20 is there. So it's a power. In order to eliminate the power, the opposite of that power means the square root of the other side. Therefore, square root of 220 or 2.096, right? Equal. You can see now 1 plus I is in the right hand side of the equation, right? So you know that here square root 20 square root means 2.0961 20th, right? 1/20th of 2.096, right? We will find it. Press 2.096, press the power button, and then you know 20 means 1/20th, right? 1 out of 20. Therefore, 1 out of 20, you can get the answer as, for this part, 1.037694617, but I'm taking only 4 digits, right? Equal 1 plus I, right? Therefore, here still the 1 is there, plus 1. The opposite of that plus means minus 1. Therefore, you can you press 1.0346 minus 1, then you can isolate I, right? Then the answer would be 1.0376 minus 1 means 0.037694617 if you use the whole number. But if we get these 4 digits only, the answer would be 0.0376. Then as a percentage value, because the interest we have to keep as the percentage, therefore we have to multiply it by 100, then the answer would be 3.76, right? This is the thing that you have to follow. Okay, so with that, we can wind up the today's session. So if I give you the wrap up session, from beginning, we learned what is the time value of money, why it is important, and then we directly go with that, went with the simple interest and compound interest, and then future value, present value, and then nominal interest rate and effective annual interest rate, right? So in the effective annual interest rate, always the frequency of compounding is there, but nominal interest rate, the contractual interest, right? There is no any frequency of compounding adjustment, but when it's come to the effective annual interest rate, it is there, right? And then we learn the annuities, right? The ordinary annuity, future value of ordinary annuity, and then future value and the present value of ordinary annuity, and then annuity due and present value of annuity